This presentation overviews the concept of normalization in reference to relational database, brought to you by Leron Macaulay. The purpose of good database design. An efficient database is not redundant, with minimum missing data entries. The main advantage of relational database is to reduce file storage space that is required by the primary tables. We do that by grouping columns into tables. The following set of rules are required to create an efficient database. Rule number 1. Each table should correspond to a single entity. What that means is that you cannot have information about two entities in one table. To avoid this, ask yourself what the table is about. Here's an example of non-efficient and efficient table structure. At the top, we show a non-efficient table that includes patient information, first name, last name, and encounter information. If we ask ourselves what the table is about, we understand that patients and encounters are two separate entities. Keeping encounter in a patient table will result in blank entries and missing data. For example, encounters with missing patient information or patient information with missing encounters. That's a lot of storage to lose. An efficient structure separates an encounter table and patient information into two tables. This type of structure minimizes the blank entries in a dataset. Rule number 2 states that each row in the table is a single occurrence of the entity. Building up on our previous example of patients and encounter tables, each record on the patient table is an occurrence of a single patient, and each record on the encounter table is an occurrence of an encounter. The third rule states that the primary key identifies the occurrence of the entity. Primary key should be unique to each row. First or last names are often not appropriate primary keys, as they are not unique. Choosing an ID or social security number are unique identifiers. Rule number 4 states that all fields in the table are facts about the primary key. Let's look at our patient table again and think why a diagnosis does not belong in a patient table. Is diagnosis a fact about a patient? Diagnoses consider a feature of a patient rather than a fact. Additionally, patients often have more than one diagnosis, which means it is not a single occurrence. Therefore, it belongs in a separate encounter table. Rule number 5 states that we cannot display a fact in multiple places in the database. Data duplication is redundant. It defeats the purpose of SQL. The data is stored in different places, and we query it based on need and outcome. Normalization is the building block of a relational database. It helps reducing data redundancies and to eliminate anomalies through a series of stages called the normal forms. We have the first normal form, second normal form, and third normal form. The highest level is not always desirable. First normal form says that all fields contain only atomic, non-repeating values. Atomic means it is not composed of two facts, and non-repeating means that there are no duplications to the data entry. In other words, the intersection of every column and record contain only one value. The first normal form is critical for relational database. The rest are optional. Let us look at the provider table. Notice that in the telephone column, two telephone numbers are listed for provider 8914. This is a violation of the first normal form. Two phone numbers are not considered to be an atomic value, they're considered to be a composite value. We solve this by creating a separate table that stores telephone number. The relationship between non-primary key columns and primary key column is said to be functionally dependent. Column B is functionally dependent on column A. In other words, if we know the value of A, then we know the value of B. This relationship is not always mutually exclusive. For example, if the telephone number is a practice number, then more than one provider can be listed under the same number. Therefore, if we know the telephone number, we don't necessarily know the provider. However, if we know the provider, we know the telephone number. Second normal form. A table that is in the second normal form first satisfies the condition of the first normal form. Additionally, every non-primary key column is said to be fully functionally dependent on the primary key. An attribute is considered fully functional dependent on another attribute if it is not dependent on any smaller subset of attributes. In this example, which was taken from Rick Sherman's book, Business Intelligence Guidebook, we see that the second table, Student Course, has course ID, course name, and course major. Course name and course major are a subset of course ID. In order for the table to be in second normal form, a course table was created to store the course name and course major. If attributes are not dependent on the primary key, place them into a separate entity. Once a table is in the second normal form, we are guaranteed that every column is dependent on the primary key. The third normal form says that no combination of facts determine the value of another field. All non-primary key columns can be worked out from only the primary key. The third normal form focuses on the relationship among other columns. Third normal form tables also satisfied the condition of first normal form and second normal form. Additionally, every non-primary column is dependent on the primary key column and independent from other columns. For example, in the table we see here, we have patient ID, first name, last name, street, city, state, and zip code. The relationship between city, state, and zip code is called transitive dependency. If we want to apply third normal form, then the city and street need to be separated into a new table with zip code as its primary key. In summary, data normalization is the process of splitting up data to avoid redundancy by moving repeating groups of data into new columns. In this presentation, we introduce three forms of normalization. Only the first one is required for a relational database. By applying the basic principles, tables can be utilized by a wide variety of users.